Hello everyone. In this video, we will see basics of neural network. So first question is, what is ANN? That is artificial neural network. Artificial neural network tries to mimic the human brain. As human learns from his or her past experience and takes decision next time on its own, artificial intelligence will also learn from the given data and later predict the things from its previous learning. So let's first see superficially how human brain works and how artificial neural network is mapped to it. Human brain consists of biological cells called as neurons it and its complex connection. Let's see the structure of single neuron. Neuron accepts the data from the other neuron through something called as dendrites. A complex chemical reaction will take place in the body of this neuron, and if the output is greater than certain threshold, then that output will be forwarded to the other neuron on axon. So same working feature is considered while building the artificial neural network. So let's try to understand artificial neural network with an example of house price prediction system. Suppose a given dataset includes two important features: area in square meter represented as x0 and distance from basic amenities in kilometer represented as x1. We have also the actual values that is represented by amount y. Each row in the table is called as training example on which neural network will learn. X1 and X0 are called as inputs, and we are expecting our neural network will identify the amount y automatically for the upcoming x0s and y0s values which our neural network haven't seen yet. So let's see the structure of artificial neural network. Artificial neural network includes single neuron. It accepts x0 and x1. Initially, we don't know what is weights. Weights are randomly initialized, but basically this weight is going to indicate how much that important feature is. If we are assigning higher weight, then it indicates that that feature is most important in order to determine the y value. It takes another input that is called as bias for each neuron in the neural network. Its value is generally fixed and it is 1. So the neural network is simply the multiplication of all the inputs with the corresponding weights and its summation along with b. So it is just trying to identify the linearity between the dependent variable and independent variable. Here in this case, y is called as dependent variable as house price is dependent on x0 and x1. x0 and x1 are called as independent variable. So we are trying to identify what will be the predicted value y cap. Bias is just used to shift the linear line from the origin 0. So W transpose X plus B is very similar to Y is equal to MX plus C. So we are trying to capture the linearity between X and Y. Now let's see how it, our neural network is learning from the given data through a diagram. So we have input values. So we have x0, x1 in this. Our model will take x0, x1 along with the randomly initialized weights, and it will identify the predicted value y cap. But obviously y cap will not be same exactly to that of y. So loss function comes into the picture. It will identify what is difference between the actual value and the predicted value, that is y and y cap respectively. Loss function value will be taken by optimizer, and it will decide how to update the weights, whether to increase the weight or whether to decrease the weight, so that output of loss function will be minimum 1. So for each training example, model will try to learn the new things, and optimizer algorithm will help it to update the weight so that loss is minimum. At some point of time, error will be very less, and that is actually the point where we have to stop. So this all these things are included in the learning stage. Now next time, if we are providing new unseen values for x0 and x1, it is expected that our model will predict its house price with less amount of error. So this is when we are going to identify the linear relationship between the dependent variable and independent variable. But the linear function has lack of the learning power. If we want to learn the complex equations which will have a degree greater than 1, then it fails. Another case is when we want to learn the when we want to work with unstructured data like image, speech, video, audio, or text. Linear function fails to identify the relationship between dependent and independent variable. So we have solution for this, and solution is adding non-linearity function in the neuron. There are different non-linear functions available. First is sigmoid, then we have tanh, ReLu, Leaky ReLu, and finally we have Softmax activation function. So let's see how to add non-linear function and where to add non-linear function in the neuron. So same thing, we have x0, x1 as an input. We will randomly initialize weights as w0, w1. Then we have bias, and ultimately we are going to identify linear relationship between x and the actual y. But if the dependent and independent function dependent and independent variables are non-linearly attached with each other or non-linearly related with each other, then we have to add fz. Fz is actually working as a non-linear function in this case, which will squash the z value in certain range, and based on that we will identify the output, that is y cap. Now without wasting time, let's see what is meant by sigmoid. So sigmoid function is y is equal to sigmoid of w transpose x plus b. We are going to represent w transpose x plus b as z. So sigmoid function will be sigmoid of z is equal to 1 upon 1 plus e raised to minus z. The corresponding graph is presented in the diagram. So the red curve is indicating the output of sigmoid activation function. So the output will vary between 0 to 1. If z value is very large, then we are expecting our sigmoid activation function should output as 1, while if the output is very small, if z output is very small, then sigmoid activation function should provide value close to 0. Now let's see whether it is working as this with the formula. If we have higher value for z, then e raised to minus z will be close to 0. So we will ignore this, and 1 upon 1 we are getting as 1. On the other hand, if z value is very small, if the z value is very large, then the output of sigmoid 0 will be close to 0, because 1 divided by very large value will be close to 0. Generally, this sigmoid activation function is used in the last layer of the neural network for binary classification. Next is tanh. Tanh is shifted version for sigmoid. It provides better centroid to 0. The formula for tanh is e raised to z minus e raised to minus z divided by e raised to z plus e raised to minus z. The curve for tanh is represented in the figure. It is same as that of your sigmoid activation function, but it is centered at 0. We can use this tanh activation function in the hidden layers of neural network. But there are certain problems with sigmoid and tanh. We can observe that slope of curve is very small with very high values and very low values for z. So we are expecting from the nonlinear function that it should have the larger slope so that learning will be fast. But here in this case, for higher values of z and lower values of z, we have very small slope. In such regions, the learning will be very slow. So the solution for this is ReLu and Leaky ReLu. So let's see what is meant by ReLu and Leaky ReLu. ReLu stands for Rectified Linear Unit. A simple function is available for ReLu, max of 0 and z. Means what? We are expecting z value as it is if the value of z is greater than 0. But if the value for z is less than 0, then we are taking 0 as an output for ReLu function. It is mostly used in large neural networks. Learning will be faster compared to sigmoid and tanh as the slope is large. But here also we have facing certain problems. If the value of z is less than 0, then we are taking 0 as the output for ReLu activation function. But it will result in the dead neurons. Remember this, we are taking W transpose X plus B. So if we have W transpose as 0, then we are just removing that feature and we are just only considering the bias term. So we will say such neurons are dead neurons and those are not useful, more useful for learning the things. So researchers has introduced the new nonlinear function called as Leaky ReLu. So leaky ReLu is almost same as that of ReLu, but with small modification. So instead of directly taking 0 as from the max function, we have attached small multiplying factor to z. Its value is 0.1. So the actual output, the output from the leaky ReLu function will be max of 0.1 into z or z. So it will introduce small slope to keep that neuron alive. Means some kind of learning will be there in the neuron. Last activation function is Softmax activation function. It is generally useful in multi-class classification problem. So till now we have learned sigmoid activation function, tanh activation function. These are very useful in binary class classification problem where we are expecting zeros or ones. But what if we have multiple classes are present, means we want to identify whether the given animal is cat, dog or horse. In such cases, softmax activation function plays an important role. It provides output in terms of probabilities. So suppose we have predicted y1, y2, y3 values are 1.2, zero point 0.9 and zero point 0.4 respectively, and we want to take the probability distribution function for such values, then we can use softmax activation function over there. Probability of yi is equal to e raised to yi divided by summation of e raised to yi, where I is ranging from 0 to n. This is the formula. So let's try to solve this. Y's value are 1.2, zero point 0.9 and zero point 0.4. We have calculated e raised to yi and corresponding values are 3.3201, 2.4596 and 1.4911. We are taking its summation and it is 7.2708. Finally, we are trying to identify the probabilities. 0.46 correspond to 1.2, 0.34 corresponds to 0.9, 0.20 corresponds to 4.0. If we take addition of all these values, it will be close to 1. Since we are dealing with the probability, summation of probability will be close to 1. But this, up till now, we have learned only what is meant by neuron. But single neuron will be performing some specific tasks. So if we are dealing with the complex activities, then we have to put all these neurons in layered way. So let's try to understand how many layers are there in neural network and how neurons are connected with each other to form a complex neural network, artificial neural network. So suppose we have three inputs x0, x1, x2. Now these three features are there. These three features will be taken by the first layer called as input layer. How many features are there? That many neurons will be there in first layer, that is input layer. Currently we are dealing with three important features, so it will include three neurons in it. The last layer will also include the number of neurons equal to number of classes. Means currently I am dealing with identifying whether the given image is of cat, dog or horse. That's why we will add three different neurons in the last layer. Last layer is called as output layer. Whichever the layers present in between input layer and output layers are called as hidden layers. Hidden layers might be one hidden layer, two hidden layer, three hidden layer, so on and so forth. Every neuron in each layer will be connecting every other neuron present in the next layer. If this is true for each and every neuron present in the neural network, then it is called as feed-forward neural networks. There are multiple variations of neural network, but for the time being, we are looking at the simpler one called as feed-forward neural network. Different variations of neural network we will study in the next subsequent videos. But this is overall the layered approach. Every neuron will be connecting to every other neuron present in the next layer. Remember this, neuron in one particular layer is not going to connect the other neuron present in the same layer. So this is all about layered approach. Now the question is where to use such kind of artificial neural networks. Now you can use this artificial neural networks where we don't have the deterministic algorithm. For example, handwritten digit recognition. So every per particular person has its his or her own writing style of one. One particular person will write one with slightly slanted line. One particular person will write exactly vertical line to represent one, and many more variations are there. So we cannot write down the deterministic algorithm for each type of one. There will be definitely variations, and we are not going to write down the program for identifying one for each style. So in such cases, artificial neural network will play an important role. If we don't have the fixed output, and if we want to predict the things, in such cases also we can use artificial neural network. For example, we want to identify whether the given mail is spam or ham. Will it rain tomorrow? So such kind of questions we can deal with artificial neural network, because artificial neural network will try to learn from the previous data and will predict the future. It will also handle the time series based data like predicting stock market price, recommendation systems, and so on. So it will try to identify which was past trend and what will be the future trend. So in such cases, we can use artificial neural network. This is not the complete list where we can use the artificial neural network, but we will discuss all the applications of artificial neural networks in the upcoming videos. Thank you for watching the video.